Today we're going to talk about how chemists describe the properties of matter, and when something changes, how do we describe that as well? Matter is defined as anything that has mass and volume, which means you can put it on a scale and figure out how much it weighs, but you can also calculate how much space it takes up. Chemists describe matter by taking observations. These observations can be classified into four main categories. If you're discussing about the properties of a substance, either physical or chemical, you are describing the characteristics of that substance that you can observe. But we also can change the substance by altering its characteristics. We can do that through a chemical change, or we can also do that through a physical change. So if you're observing a substance and something happens to it and now it looks different, we describe that through changes, either physical or chemical, as opposed to describing that as a property. So let's first talk about the properties. A physical property is something that you can describe and that you can measure without destroying your original substance. You have a substance to start with, you make your observation, you have that same substance when you're finished. So you can describe its state. Is it a solid, liquid, or a gas? Malleability, can you pound into a sheet? Here are several examples of physical properties that you can observe about a substance. You can look at a substance and describe its state, whether it's a solid, liquid, or a gas. You could also look at the substance and describe its color, its odor, or whether or not the substance is malleable. And what we mean by malleability is, can you pound it into a sheet without it breaking? So for example, like iron's malleable. For ductility, if you're describing how ductile a substance is, you are asking, can you stretch it into a wire? So copper, for example, is a ductile substance. You could also describe a substance's hardness, its melting point, its density, which tells you does it float or sink, and also its solubility, does it dissolve in water? If you describe any of these things or observe any of these things about a substance, you don't change the actual substance that you have. For example, if I have some water, hey, it's a liquid state, it doesn't have a color, it doesn't have a smell, it's not malleable, I can't pound it into a sheet with a hammer. These are physical properties because by making those observations, I don't actually change the chemical composition of my water. I started with water, I made my observations, I still have water when I'm done. In contrast, a chemical property describes how one chemical reacts with other substances. And when you observe a chemical property, because you're doing a reaction, you don't have your original sample left once you're done. Some examples of making observations of chemical properties is seeing, does your original substance react with water? Does it rust? Is it flammable? Is it poisonous? Does it decompose or does it fall apart when you heat it? If you make these observations, then you don't have your original substance left over. If you start with a substance, you heat it, and it falls apart and creates something new, describing that process is what's called making an observation about a chemical property. Pause the video here and see if you can classify these observations as either being physical properties or chemical properties. Remember the fundamental difference. If it's a physical property, you start and stop with the same chemical. If you're describing a chemical property, you're going to not have your original substance after you're done making your observation. Here are the answers. Check and see if you got them right. I found only 3 chemical properties. When copper turns green when exposed to the environment, well, that's a chemical property because that green stuff that you're seeing is not copper anymore. It's something new. Also down here, when sodium reacts easily with other elements, because you're describing a reaction which will change the sodium into something else, that's going to be a chemical property. And down here, the last one, hydrogen is flammable. That's a chemical property as well. Because if you test to see if hydrogen is flammable by lighting it on fire, you're going to create something new. You're not going to have hydrogen left over afterwards. So that's why it's a chemical one. All the rest of these examples are physical because the substance that you're observing or measuring doesn't change. Now let's talk about physical and chemical changes. If you start with one substance and you do something to it, then we have what's called a physical change or a chemical change. Here's what the definition of physical change is. When you describe the change in the appearance of something, but you don't create a new chemical during that change. So this means you still have the same substance before and after. It just might change a couple of its characteristics. Here are some examples of physical changes. If you changed a substance's texture, or its shape, or what size of the sample you have, or what volume you've got, or the mass of the sample, or its density, or its state, or if you dissolve something, these are just physical changes. You start and stop with the same substance. For example, if I start with a block of ice, and then I take a hammer to it and break it up into smaller pieces, that's going to be a change in size and shape. But I started with ice. I still have ice when I'm done. That would be an example of a physical change. The tricky one here is the dissolving something at the bottom. Sometimes people think that that's a chemical change because you're making something new. But you still have the same chemical particles in your container when you do this. You can prove this by thinking about dissolving salt in water. If you take some salt, put it in water, it will dissolve, and then you make a salt solution. You'd have some water particles and you would have some salt particles. To prove that this is a physical change, you can actually separate the salt in the water back. If you take your salt water and heat it up until it boils, all the water will boil away and you'll get your solid salt back. You didn't create a new chemical, it's just you have a mixture and then you can separate it back into its components. So this is a physical change because no new chemical substance was created. If you're observing a chemical change, you're looking at a reaction which creates a new substance or a new product. There are 5 signs that a chemical change has happened. If you see a reaction, you are either going to see a new gas forming, which you usually see bubbles being made. You see a brand new solid being formed. So if you take 2 liquids and mix them together, and then all of a sudden it gets chunky, that would be an example of a new solid. Or you see a new color made if something goes from red to blue. Or if a new smell is made. Or if you see or feel heat or light being made. Now, you don't have to see all 5 of these signs to call it a chemical change. Just 1 or 2 will do. You do have to watch out because some of these clues or signs of a chemical reaction can be a little deceiving. For example, if we have a look at this picture here, boiling water on a stove, you see, hey, I see some new bubbles here. But this is really just a physical change. I'm taking water, that's a liquid, and now I have water as a gas. That's what those bubbles are. Because I started with water and I still have water, then that's just a physical change. Not every time you see bubbles is it a chemical change. If you look over here on the picture of the egg, you also see bubbles forming. This is a sign of a chemical change, but also too we have this other sign. If you fry an egg, the egg goes from being a clear or a yellowy color to this nice white color. So now I have 2 signs of a change. So frying an egg, definitely a chemical change. I have bubbles and I see a color change. Remember I mentioned down here dissolving can sometimes be confused as a chemical change. That's because sometimes when you dissolve a substance in water, you get a color change, right? Water's clear and colorless, and then if you put some Kool-Aid in, then hey, now your water's a different color. But again, if you wanted to separate the Kool-Aid powder from the water, you could boil the water away and you would get your colored Kool-Aid powder back. It is just a physical change when you dissolve something in water. So what do you think about these changes? Pause the video here and classify them as either being physical changes or chemical changes. And remember what the difference is. A physical change, you just change the appearance of your substance. You still have the same thing before and after. As opposed to a chemical change when you're creating something new. A new chemical is made. Pause the video here and classify these. Here are the answers. Sugar dissolving in tea, hey, that's just a physical change. Whenever you dissolve something in water or any other liquid, just physical. Number 2, if you break water up into hydrogen and oxygen gas, hey, we're making new chemicals. So this is a chemical change. If you're burning a log in a campfire, hey, there's a lot of heat and light that comes out of there. Also, we make a new solid. That's that ash or soot that's left over. So that's a chemical change. But crushing an aspirin up, that's just physical. You had solid aspirin before, you grind it up, now you have aspirin, but it's a powder. We're just changing the appearance, physical. Metal rusting, that's a chemical. The rust is actually a new substance. Lighter fluid burning. Well, we don't have the lighter fluid after it's burned. It disappears. That's chemical. An egg rotting, usually there's a new smell with that, and some new colors. That's going to be chemical. Boiling water, hey, that's a physical change. And question number 9 asked you about the test tubes in this picture. Do you see how in this first test tube here, I have a yellow solution and I put it in a clear solution and now it's a red? Hey, that's a new color. That's a chemical change. But if I take a yellow solution and mix it in a clear solution and it still stays yellow, physical change. I have no proof that I made something new. Now try out the worksheet to practice classifying observations as being physical or chemical properties or physical and chemical changes.